this lesson, you will learn to identify the appropriate model for representing a given situation and know the steps used in creating a simulation. The purpose of a simulation is to create a model that represents a given situation in order to make predictions on the future behavior of that given situation. Simulations can also be used to get a sense of the random behavior of a particular model. We will discuss some of the different types of simulations that we can use to predict the behavior of different models. The goal for us is to get a strong sense of what is happening in a situation and make conclusions based on your observations. Let's say you're playing a game with a spinner, and you win if the spinner lands on blue. The chart shows how many times the spinner landed on each color after 30 spins. We could expect for it to land on blue about 1/4 or 25% of the time. Since 1/4 of 30 equals 7.8, a frequency of 8 or even 9 would be expected. Is a frequency of 5 so off that we might think this spinner could be broken? Let's take a look at how simulations are modeled, how they can help us answer this question, and we'll see if the situation makes sense or if the spinner really is broken. When doing a simulation, the goal is to create a situation that represents the actual possible outcomes. For this situation, you could create a spinner using a paperclip and a pencil. Or we could use a 4-sided die or a bag with 4 different crayons inside. Whichever model you choose, make sure that it accurately represents your actual situation. For example, you wouldn't want a bag with 6 crayons to represent a situation with only 4 possible outcomes. If you are simulating flipping a coin, you would want a spinner with only 2 colors, not 4. For this simulation, I used a spinner made with a pencil and a paperclip. The steps in a simulation procedure involve 1. Describing the problem. Is the spinner landing on 10 blue unusual? What is the range of numbers you would expect to see, given that you have a fair spinner? 2. Identify any assumptions. The probability of landing on each section is 1/4, since each spin is independent of each other spin. 3. Describe your process for obtaining results. Communicate how you are getting your results. So go ahead and spin the spinner and record the color the spinner lands on. Repeat this 30 times. Or if you're using a bag with crayons, then shake the bag of crayons, pick a color, record your results, put the crayon back, and repeat this 30 times. Go ahead and try it. Pause the video and spin your spinner 30 times and record your results. 4. Repeat the process. This is tricky. No one really wants to do this many times, so we can use technology. There are websites, apps, and programs with simulation tools we could use to run simulations and gather the data without having to physically run through the simulation multiple times. 5. Evaluate and interpret your results. How many times did it land on blue? Take all those trials and graph your data. A frequency table is often used to organize this type of data. I ran the simulation of spinning the spinner 90 times and graphed my results on this frequency table, showing how often the spinner landed on blue. Take a look at this table and see if you notice anything interesting. Based on running our simulation many times, we can see that getting blue only 5 times is not that unusual. Now it's your turn. A coin is flipped 100 times and it lands on heads 66 times. Is this coin fair? List the steps to creating a simulation to help with your decision. Pause the video to work out the following problem. Click play to continue. Let's look at how we could solve this using our simulation procedure. For this situation, our first step is defining the problem. So we just state the question, is the coin fair? Next, we list our assumptions. We assume the probability that a coin will land on heads is 1/2 or 0.5, and the probability it will land on tails is also 0.5. Each flip does not affect the outcomes of any of the other flips. Then we describe our simulation. I created a spinner that is divided into 2 sections. Once we have our simulation model, we need to repeat the process. 50 times is a good amount, but the more times you repeat it, the better. Finally, we determine if getting 66 heads is unusual. Take out your notes and make sure you write down the purpose and the procedure for simulations. The purpose for creating simulations is to create a model that represents a given situation in order to make predictions of the future behavior of that situation. The procedure for running a simulation can be summarized with the acronym PADRE, P-A-D-R-E. P stands for problem. In your own words, describe the problem. A stands for assumptions. Define your assumptions. D is for describe. Make sure you describe your process for obtaining your results so it can be replicated by someone else. R is for repeat. Repeat your process. E stands for evaluate. Make sure you evaluate your results. In this lesson, you have learned to identify the appropriate model for representing a given situation and know the steps used in creating a simulation. See you in the next lesson.